infant social development, part 1, part 2. Today we're going to do infant cognitive development, okay? So basically we want to understand how is it that people develop cognition, okay? How do you develop it? How do you assess it? What is it, right? What is your cognition, okay? So it's a very complicated group of mental abilities. I mean, if this was us in the lecture, I would ask you, okay, as to what do people think mental abilities are, okay? So generally your cognition in lay terms is kind of like your understanding of things. Like, do you understand? Do you comprehend? So it's a bunch of things, okay? So we call those mental abilities. So this is just, you know, a sample of, and there's a lot more. So your memory, your thinking, your problem solving, your ability to categorize, your ability to reason. How does your language develop, and how does your language aid you, help you in all of the above? Okay, so sometimes people with a language development have problems with memory because their reception of the language is construed or not proper, and therefore it affects how they encode things that they are trying to learn. So language is really integral to a lot of your skills. But does that mean that people who are language delayed are not intelligent? Okay, so that's kind of a question out there for you. You can send it in the chat. So are people with language development cognitively impaired? Does language delay cause delay in your overall intelligence? So there are so many approaches to understanding cognition, and just again, keep in mind, we're talking about children. So how do you understand how kids start to understand anything, okay? So there's generally 4 approaches, and we're going to go over those today. So the first is Jean Piaget, and he's like, let's say, a milestone, or like a figure when you talk about cognition and its development. So his name is like essential because he was essential in the development of so many of the theories related to cognition. Then there's something called the nativist approach. Then there's information processing, and then there's the psychometric approach. We're going to go over all of these as we go along. So the first is Jean Piaget. The language, maybe, again, I'm going to go over it. If there's difficulty, you can raise your hand or again, put it in chat. So Piaget, he proposed a theory of infant development, and it's really organized around 4 main themes. So he looks at the object, okay, whatever the object is, and how it behaves in space, all right, over time, and if there's anything that's going to affect it. So looking at cause and effect, okay, so it's very physical, if you will, to understand how things behave in their environment, in their space. And so the principal goal of his theory was to really explain something that's really essential as a concept, and it's called objectification, okay? And what that means is to know who you are, okay, so to know yourself, and to know that you are distinct and separate from the world. You're not like one piece of like, you know, you're not stuck. So you are you, mom is mom, there is space in between. And to know that there's a persistence over time, and then there's going to be a cause and effect. How am I going to be affected by the world around me, and how will I affect the world? Okay, so it's, again, it seems very physical, okay? So we have our senses, our 5 senses. So we see, we hear, we smell, we taste, we touch. So these are all input areas, okay? So all of that is sensory information coming into our system, and obviously it causes neuronal excitation, and therefore, you know, I'm not going to get into the actual anatomy and physiology of how do we see, how do we smell. That's something that you're going to be taking, and if not already have taken. But we're talking about sort of another level of all of these sensory inputs, okay? So you have a sensory image, okay, and then you have a pattern of neuronal excitation. And then you have an activation of particular neurons that are, relative to the area. So, things related to vision, related to smell, to taste, to touch, okay? And then these will cause mental representations, okay? So very important concept is schemes and prototypes. We've talked about prototypes when we looked at social development. Now we look at schemes or mental representations, okay? So a cognitive process then involves the transformation of this mental representation into something that's a lot more elaborate, okay? So there is a smell, okay? And then it goes in and it causes the whole olfactory sort of system stimulation. But then there has to be a connection to somewhere in the brain that then identifies, is this a good smell or a bad smell? Okay, so every time you walk down a road, a particular path, you always smell a really negative smell. It's a dirty kitchen or it's a dumpster or whatever. So then you form an association between a place and a smell, or a person and a smell. Remember when we talked about how babies, smell their moms? And so it's that connection. So there is a representation of that smell and how that becomes connected to mom. So that smell equals mom, right? So it's transformed from just an olfactory system sort of excitation to now a mental representation of every time baby smells that particular smell, it automatically represents their mom. So objectification is a major cognitive achievement, okay? So it takes place in the first 2 years of postnatal development. So this number 2, is a very important number, and objectification is a very important concept, okay? He called the first 2 years of life the sensory motor period, okay? And again, we're talking about the development of schemes. So these are like imprints that develop and they become a reference to whatever we're going to face later on in our life. And again, remember when I talked about numbers and ages, so this is important to know. So Piaget talks about 4 stages. The sensory motor stage is from birth to 2 years. Then you have the pre-operational stage from 2 to 7 years. Then you have a stage of concrete operations, 7 to 11 years, and then formal operations, 11 years through end of adolescence, and we're going to discuss those in detail. He spent a lot more time on the sensory motor stage. It's the first 2 years of life, but a lot is really happening in a relatively, let's say, short time. So 2 years is not a very lengthy time frame, but a lot is happening. He divides that into 6 stages, okay? So the first he calls stage 1, or the modification of reflexes, and it's from birth to 1 month. Now, infants, again, in the first few months of life, their main function is feeding. So their connection to the outside world is really based on what goes in their mouth. Are they fed? What are they fed? Is it feeding on time, feeding on demand? So all of these variables affect the whole experience, okay? But you'll study that in pediatrics, but you have the sucking reflex. So when you put your finger next to a baby's mouth and you just go like that, the reflex is that the baby's mouth will move towards your finger, and that's, subhanAllah, the reflex mechanism in order to initiate feeding. So again, this reflexive behavior is very much responsive to stimulation, depending on what it is that you put inside the baby's mouth, okay? And so then these reflexes start to become more complex, okay, to meet the requirements of different circumstances, okay? So obviously start off by babies are fed milk, but even in that, it could be warm milk, it could be cold milk. And if a baby's more used to warm milk and then you give them colder milk, they're more likely to spit it out. So even their reflex behavior can change based on the type of stimulus they receive and whether they like it or they don't. Stage 2 is called primary circular reactions, and it's from 1 to 4 months. So a circular reaction is anything that's repeated. So it's a circle, so it's kind of a repetition. And if it's called primary, yes, hello? Okay, did someone want to say something? Okay, so it's primary because it's interesting and it really serves to explore the world. So this reflex becomes a scheme, okay? It becomes sort of a representation of of exploration of the environment. Whether I want to, again, for 1 to 4 months, it's you're progressing from just purely milk into adding a little bit of like Cerelac, or things that are a little bit processed, and then babies will taste and then respond based on whether they like it or they don't. Stage 3, he called secondary circular reactions from 4 to 8 months. Now, if you remember here, kids can reach out, like looking at their motor development, so they can reach out now. By 6 months, they can sit. They have better control over their heads. So again, it's important to consider the motor development when you're looking at cognitive development. So here you have an activation of schemes to produce an event in the world. So an example of this would be, a baby holds a rattle, that thing that makes sound, and they just shake it, okay? There's not much purpose other than production of sound. All right, so now they're able to reach out, they can hold, you give them this thing and they're trying to experiment with it. What does it do? They shake it, it makes sound, okay? Then you move on to stage 4, which is more a coordination of these secondary schemes, okay? So here, there's more of a goal and a plan to reach your goal. So an example would be, and again, visual acuity is definitely a lot more improved here. It's normal. So you have toys in front of this toddler infant, and then you put your hands between the baby and the toy. And so they're going to push your hand away because they want to reach that toy. So here it's called means end. So they're doing something to reach something. If you had showed the baby the toys earlier on when they're 4 months old, they would not have the intention of trying to reach them. Okay, they'd be maybe more interested in your hand and trying to sort of touch your hand, but they're not yet cognitively aware of what's behind your hand or wanting to reach it. Now, tertiary circular reaction, so 12 to 18 months, this is when kids are moving. So they're up, walking, and sort of more into things. So here, they're really interested in things that are novel, and it's really partly exploration. So here, they start to do things like dropping objects because they want to see the cause and effect, okay? So again, it's a dangerous time because they're already walking, they're able to pick up things, and then, they can drop them down a flight of stairs, could end up on anybody's head, or so injuries are likely. And it's here, again, it's part of experimentation with sound and the physics of it. If it falls, is it going to splatter? And they're interested to see that. 18 to 24 months, so here you're reaching the 2-year mark, okay? The cognitive abilities are developing quicker. And so here they have mental representation. So by the age of 2, kids don't have to try every single thing before, they know that it's okay or not. For example, at the age of 18 months, you taught your child that this is hot. So they touch it, it's hot, okay? So when they come in contact with an encounter with something else that's hot, in a normally, cognitively developing 2-year-old, sometimes it may be enough to say this is hot for them to understand and not actually go ahead and touch it. Versus if they were just 12 months of age, that would not really be hitting home with them. They wouldn't really get the concept because they don't still have mental representations of what hot could mean. Okay. Now, an interesting concept, and I'm going to show you a video about it in a second. In transition from stage 4 to 6, okay, there's something called the A not B error. So a baby in the stage 4, okay, which is younger than 2 years of age. I think I'll show you the video first, and then we'll explain it. Maybe that will make it easier. Okay. Mhm. Is the sound okay?
Doctor?
Yes.
Assalamu alaikum, doctor.
Alaikum salam.
Actually, doctor, there is no sound.
Okay, let's see what's the problem.
Thank you.
Is there still?
Yes, doctor, still there is no sound.
Okay, so I'm not sure why that is. RTA, are you around?
Doctor, maybe your, I don't know, maybe your system volume is low. Not sure.
I'm not sure how to fix that. What do you suggest?
Okay, doctor.
Can you share it from your screen?
Oh, okay, doctor. Doctor, if you go up to this, if you go up, you can see that you are sharing screen, right? There's a green.
Yes.
Yes. Okay, doctor. So when you go up, you can see an option like to click that says more.
It says more, okay.
Can you see it, doctor?
Should I share computer sound?
Yes, yes.
Let's see if that works.
You ready?
Is it okay?
There he is.
Doctor, it's working.
Very good, Dana. There he is.
Still no sound?
Hello, doctor, we can hear you.
Yes,
Can hear
doctor,
the
it's
There
working.
he is. There he is. He's got two eyes. Boop, 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 boop. Boop, boop, boop. Can I have the monkey? Here we go. Boop, 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 boop. You're holding on tight this time. You're holding on tight this time. There he is. There he is. Where is it? Oh, there he is. There he is.
Okay, I'm just going to explain it and then maybe we'll go back to the video again. So what happens is usually they're going to look, the stage 4 infants, the younger ones, are going to look for the object in the first place where they saw it hidden and not in the last place where it actually ended. Okay, if you remember in the video, she hid it initially on one side, okay, and that's where he looked for it. And then when she hid it in the other side, the stage 4 is still looking for it in the place where he first saw her place the object. So let's just show that video again. So as they get older, so closer to age 2 and above, they're actually going to look at the place where she last put it, not where she first put it. Okay, so let me just play that video again for you.
Ready? There he is. Very good, Jana. There he is. There he is. There he is. He's got 2 eyes. Boop, 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 boop. Boop, boop, boop. Can I have the monkey? Here we go. Boop, 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 boop. You're holding on tight this time. You're holding on tight this time. There he is. There he is. Where is it? Oh, there he is. There he is.
Okay, so is that clear? He looks in the place where he first saw her put it. Okay, somebody was asking, why is the baby crying? I think it's because she took the toy away from him or her. Okay. All right, another concept, it's called the allocentric system of spatial organization, and we're going to see that in a video to come. So basically, infants judge the world based on their location. Okay, so the external world is referenced to them. So if something is to their right, okay, it can't be to anyone else's left. Okay, so they believe that it's to my right. Therefore, if you're sitting in front of me, it has to also be to your right because it's to my right. Okay, so it's very egocentric. All right. They judge the spatial organization relative to them. So that's a concept, and we're going to see a video about that in a bit. So in summary, okay, for the sensory motor period. So again, the infant is learning through sensory observation. They're gaining control over motor functions. They're able to sit and walk. They're active, they can explore. Obviously, biology as they're developing and the experience, they produce this learned behavior. As they become more mobile, you have one scheme is built after another, and the critical point of development for the sensory motor period is object permanence. Okay, so at 18 months, they start to develop mental symbols. Okay, so they create visual images of, so like we said, from 18 months onwards, their ability to have a mental representation starts to increase. We move on to the second, which is the pre-operational period, and that's from age 2 to 7. So what are kids usually doing in this age? So from 2 to 7 is when they're entering nursery, going to kindergarten, and getting ready to go to grade 1. Okay. So here, language and symbols are starting to be used more freely. However, there's no logic in their thinking. Their thinking is very much magical. Remember the video that we saw last week about the 2 girls, Poppy and her sister, and their like magical thinking in their play, and Rapunzel, and that they can fly. Okay, so this is a time when kids believe that they can fly, they believe that they have magic, they believe they have power. They don't have a sense of cause and effect. So if you drop a glass, it's not going to break, or that. So they don't have that concept yet. And I think when you see it in cartoons, you know, when people fall off a building or something, what do we usually see in cartoons? I mean, we don't see bloodshed and traumatic brain injury. You see like something pop out of their head, butterflies or birds or something. And that's magical thinking. So they're unable to grasp the concept of sameness, okay? So this is an example I always give about my daughter when she was around 3 or 4, where her nursery teacher, we saw her in a supermarket. And so she was really quite confused, you know, how come she's there in the supermarket when she's also at school? And so I'm like, what's the problem? She's like, I thought she lives in the school. Why is she outside of school? So she still wasn't able to kind of grasp the fact that this person could be here, but could also be elsewhere. They're not able to deal with moral dilemmas. So it's really hard to have that moral conversation with your 3 or 4-year-old about right and wrong and virtues. And, you know, you start to teach, however, it's hard for them to have these really intense moral discussions. They also have a sense of imminent justice and that they could be punished for bad deeds. Okay, so I once saw this. She was in kindergarten, KG3, so 5-year-old, was recently diagnosed with diabetes, so insulin-dependent diabetes mellitus. And so you know, we're trying to teach her friends about, like, you know, if she feels dizzy, then tell the teacher because maybe she needs to drink something. But we noticed initially the concern was a lot of kids were kind of staying away from her. They were worried that, you know, maybe they're going to get infected from the same thing that she has, or maybe she got this because she was not a good girl, she was a bad girl. So there's that sense of imminent justice. Also, kids in that age are very egocentric, so they are the center of the universe. And we talked about this last week, where that is also essential for the development of, you know, a good sense of themselves, is to feel that they are the center. But again, it's a balance or a line between that and narcissism. Okay. Then you have concrete operations. So this is school grade 1 to grade 6. Here, thought processes are a lot more operational. They're able to kind of take in information from the outside world. They start to have more logical thought processes. They're able to form, you know, logical conclusions. So things like all horses are mammals, mammals are warm-blooded, therefore horses are warm-blooded, that kind of thing, as well as conservation, reversibility. You know, you all remember ice, water, gas, and how they're all the same and occupying the same volume. They start to have that moral sense. They're able to follow rules and regulations, and they're able to understand concepts of quantity. Now, why is that important? You know, because here you can start to teach them more mental math. They can start to understand simple concepts of physics, whereas before that, you know, if it's a 5-6-year-old, it's really hard for them to get that concept. And so Piaget's theories were really utilized in the development of syllabuses for schools, just because when we know that that's what kids kind of understand, then that's how you put your syllabus. So it's hard for a 7-year-old or 8-year-old to understand calculus, okay, because it's too abstract for them. So in this stage of concrete operations, things tend to be a little bit more concrete. Then you have formal operations. So this is 11 through adolescence. So here, your middle and upper school, more formal, more logical, more systematic, more abstract. They're able to reason. They understand probability. Language is a lot more complex. However, they say that not all adolescents enter the same stage at the same time, because you can have a 14-year-old who is not as mature as a 12-year-old. So again, and their ability to understand reason and probability. So again, it's not based on your chronological age, but really your mental age and how much exposure and experience and stimulation you have in your environment. You do meet 15-year-olds that are super naive, and again, it comes from how are they protected, how much general information do they have. So that is something to just note. So this is another video. Okay, so let's see if this one works.
New babies aren't quite sure what happens to objects when they leave their sight. Sky's mom keeps disappearing and reappearing. No wonder peekaboo is so much fun. During their first year, however, infants will learn an important concept: object permanence. Everything has a life of its own, even if it is out of sight.
At Maya's age, babies know to look for the object, but they might not have everything else straight. 10-month-old Simon is about to make a classic mistake. Although he watched us place the toy plane under the white cloth, he'll look for it where he last found it, not where he watched us hide it.
Can you look at these two glasses? Do you think that they have the same amount of juice? You think they have the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice, this glass has more juice, or do you think that they have the same amount?
That one has more.
This one has more, and why do you think that this one has more?
Because it's taller.
Okay, you ready? Yeah. Okay. Does this row have more quarters? Does this row have more quarters, or do they have the same?
1, 2, 3. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're all the same.
They're the same?
5, 5.
Okay. Okay. Does this row have more quarters? Does this row have more, or do they have the same?
This one has more.
That one has more quarters?
Yeah.
Why does this row have more quarters?
Because it's more far away.
It's more far away?
Yeah, it's more far away than that. Looks bigger.
All right, we're going to play a game with the graham crackers, and we're going to share them between me and you, okay? Okay. Do you think that we shared those fairly?
No.
No, why not?
You have those and I have this one.
Well, what if we try this? Okay, can I put this down right there?
Okay.
Now is it fair?
Yeah.
Yeah, why is it fair now?
Because we both have two.
Can you tell me what you see when you look at that from where you're sitting? What are some of the things that you see?
And a cat.
A cat.
And a tree and a bone.
Okay, now we're going to do the same thing. Can you tell me what you see when you look at it from that stool?
An owl.
An owl?
And him.
What is that?
A goat.
A goat?
Yeah.
Okay, is there anything else you see?
Yeah, right there.
Right there, what is that?
A tree.
A tree.
And that's another little tree.
Another little tree?
Yeah, right.
Okay. And can you tell me what I see when I look at this from where I'm sitting right here?
An owl.
Okay.
And a goat.
Mm-hmm.
And a little tree. And that. And that.
So first we're going to look at these two cups right here. Do you think there's the same amount of juice in this glass as there is in that glass?
They're even.
They're even? Okay. So we're going to take the juice from this glass and pour it into this one right here.
Okay.
Okay, so now we're going to look at this glass and that one. So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
Same amount.
Okay, why do you think that they have the same amount?
Just because this is skinny doesn't mean it's not the same amount. It has the same amount of juice in it, but this one is just wider and this one's skinnier, but they have the same amount of juice in it.
It says, if you hit a glass with a hammer, the glass will break.
I knew that.
And then this one says, Dawn hit a glass with a hammer.
I knew that too.
So what happened to the glass?
It broke
It broke. Why did it break?
because the hammer's hard.
If you hit a glass with a feather, the glass will break.
No, it won't.
And this is the second rule. Dawn hit a glass with a feather. What happened to the glass?
Nothing.
Nothing happened. Why didn't anything happen?
Because the feather was soft.
If you hit a glass with a feather, the glass will break. Okay. And the second one, Dawn hit a glass with a feather. What happened to the glass?
It broke.
And why did it break?
Because the rule says if you hit a glass with a feather, it'll break. So if you hit a glass with a feather, it broke.
Okay. Let's just go back to where we were. I'm just going to make a few comments on the video. Okay, so okay, so basically, what happened was a few things. Obviously, you saw when she was showing the juice to the younger child versus the older child, knowing that the fact that you changed the actual cup. Obviously, the younger kid thought the volume changed, whereas the older kid realized that it did not. The other thing in this specific picture, when we talked about the allocentric location of things, so because he saw a goat and a tree from where he was sitting, and then when he moved, and then he saw something else, so he assumed that that's what she saw because that's what he could see. Okay, so that's the allocentric. The other one about the feather and the glass. Okay, so the younger child is concrete. Okay, so that's why when she gave him the rule about that Dawn hit the glass with a feather, and so the glass broke, that's too abstract for him. Whereas the older teenager was able to get that this was the let's say the rule. Okay, and that's why she laughed, because obviously she knows that a feather is not going to break the glass, but she just understood that that was the rule, and so she just followed. And so here, because she's able to abstract think. Okay. I'm not sure why this keeps coming up. Hmm. I'm not sure why when I try to enlarge it, it does that. Okay, so we have our nativist approach, which is the second. Okay, and so here again, it's looking at trying to understand cognition. Okay, so you have early kinds of knowledge, all right, that come from certain processes. Okay, looking at how objects obey physical constraints and extrapolating from there. Okay, it sounds a lot more complex than it really is. Okay, so I'm just going to show you something to explain. All right, so you guys can see that this is like, let's pretend that this is a block. Okay, and that this is, I don't know if you see it, maybe I'll use a pencil just for the color. So what they're saying is there's a difference between how newborns and 4-month-old respond to looking at a rod behind a block. Okay, so when you see this block and then we have a rod behind it, okay, and I'm moving this rod, okay, you know by default that this is a connected rod. It's not two pieces. You know by default that it's one because you know that a pencil is one. Okay, it's not two pieces. All right, I'm gonna say what I'm gonna say and then we'll look at the chat to see if you guys have questions. Okay, so when they show this exact same model to a newborn and a 4-month-old, okay, then they remove the block and they leave a pencil, like a rod, as one, or they show two separate rods with a space in between. Okay, pretend that space is like an invisible block. Okay, so what they found is that the newborn was looking at the full rod more, which means it's new to them, and the 4-month-old was looking at the two-piece rod for a longer time because that was new to them. And what that means is that for the 4-month-old, they've already established that rods are continuous. So that became a piece of information that is already known to them. What is new to them is the fact that it is split. So that means that over time, they have learned and have seen rods as being continuous, okay? Whereas newborns, remember we talked before that generally there is a tendency to look at what is new because you already know what is known to you. So you're going to look at what is novel, what is new. So for the newborn, okay, this is what they understand. They don't have an understanding that it's continuous. So when you show them this is new to them because they are used to seeing two sort of sides of the rod. This to them is what they're familiar with. This is new. For a 4-month-old, okay, and you show them that, they already understand that this has to be continuous. So if you show them something that is split, that becomes new. And this just confirms the concept of learning, that you have learned by observation that rods are usually continuous. I'm just going to open the chat just to see if there's any question. Okay. So, so what will happen when you reveal to the new, are we talking about the same thing? Someone says, can you explain again? So we're talking about the rod and the block, okay? Can I get more yeses or nos if people understood or did not understand? If it was clear or not? So I'm just going to explain again. Okay. So some people said it was clear. I'm just going to kind of go over it for everyone again. So you show this to a newborn and you show this to a 4-month-old. Okay. So for the 4-month-old, all right, they know the concept that things are continuous. All right. For the newborn, they don't. Okay. So when you show this to the newborn, this is new to them because they've always seen it as split. So they're going to be interested to look at this. However, when you show this to the 4-month-old and you show them a split rod, they will look at the split rod because they know that they're familiar with this already. So they're going to look at what's novel. And it means that over the 4 months period, again, you can repeat with the same infant at like, a month old versus 4 months old. Again, this is, let's say, a bit hypothetical too, because we know that newborns can't really, like, visual acuity is not the greatest. But I mean, if you want to experiment with a 1 or 2 month old, and then later on when they're like 4 or 5 months old, but it just confirms that they have witnessed enough, pencils, rods in their environment to know that they cannot be split. Okay, so at 4, 5, 6 months of age, they're going to be more interested to look at one that's, up and down with space in between. Okay. All right, let's move on. So that was our nativist approach. Okay, so it kind of feeds on innate social knowledge. Okay, so Piaget talks about first true imitations at age 8 to 10, how kids will imitate. Okay, and that later on there's something called deferred imitation, and that's based on learning. Okay, so you witness something, and then later on you repeat, and that only confirms that you've learned. Okay, so example would be, kids are in nursery, kids watch other children push each other. Okay, comes home, when they're angry, they decide to push, although that's not in their environment. Like aggression or like physical stuff is not in their environment. So moms will say, like, where did he learn that? We're never violent at home, we're not aggressive. Or even with words that are not appropriate, sometimes kids learn things from the outside of home, and then, they come out in context at home, and the moms are like, we never use this kind of language. So that's called deferred imitation. So kids register, and then later on it comes out, and we're going to discuss this further when we discuss learning as a topic. Okay, so Piaget talks about the development of representation of events as a primary that can be acted out later. Okay, so you kind of have a scheme. Okay, so the capacity to imitate novel actions by the age of 9 months. Whereas this other group think that representations are a starting, not end point. So they don't think that you need to have schemes. It's almost like you're born with a template. Okay, so you have a system that is early on developed for recognition and responding to others. Okay, so it's just a difference of timing. But at the end of the day, it boils down to you need to have some kind of a representation, whether it's a template, and I think you can have templates for things that are instinctual, where it's not actually learned, okay? Whereas things that are not instinctual, you will learn them over time. Then you have the third, which is the information processing approach, okay? Here it really talks about cause and effect, knowledge that you acquire from how things behave with each other. So, when you throw, you throw a ball, it hits another ball, and then the energy, what is it? Every action has an equal and opposite reaction, something like that. And so if there's no contact, then there's going to be a delay in launch. And so kids love to kind of throw things at each other, like toys, and they see like how far does it go based on how much energy. And it's not like they're trying to test some theory. It's just an observation that they kind of go with. Okay. Then we have the psychometric approach, and this is a very objective way of assessing intelligence. So someone asks, like, can you refer a 3 or 4 month old to get their, intelligence tested when they still don't have language? Okay. So what would be the point? Why would you want to have a cognitive assessment of a 4 or 5 month old? So we usually do that when we're suspecting some kind of mitochondrial disease, global developmental delay. You see a child with like a floppy baby, like motor delay. So you want to see as well, are they cognitively intact or not, or at least seemingly so. So here it measures various aspects of an individual to understand their development. And obviously the main point is that you have to compare to a group. So there's no point of me doing an assessment of an individual with no comparison group, because then I wouldn't know where they stand under the bell curve. You know, are they within average, or are they on extreme? So the Bailey scale of infant development is something that we use. It measures motor and mental development, and it kind of tests items in a developmental sequence. And a score of 100 would be average, okay? Obviously, there's much more updated versions. I will let you know about that next time that I see you. But it's suitable for ages 1 to 42 months. Okay, so you're talking about children from birth till around 4 years of age. And it tests 5 major areas. It tests their cognition, their language, their motor development, their adaptive behavior, and their social emotional, okay? But it does not predict later IQ. So can anyone think of why? You can send me on chat now. Why do you think this does not predict later IQ? If you have a child who has a score of 100, why can't I say that, tell the parents, you know, this child is now 4 months old, their IQ is 100. Can I like bet my money on that when this child is 6 years of age, their IQ will be the same? Let me see. So the baby's still developing. There may be a delay eventually. Okay, mental abilities are still developing. Okay. The developmental delay will appear later. I mean, we usually refer, because there is a developmental delay, like we're not going to refer a 4 or 5 month old for cognitive assessment just like that. So there's usually a clinical question. So your answers are along the right direction, because, you know, they're still developing. Okay, you kind of have more, your IQ becomes more consolidated by the age of 6. Okay, because you're still developing. Also, you know, in that age range, kids are, you know, susceptible to infections, seizure disorders are, you know, commonly in that age group. So you can have medical conditions happen, you can have physical conditions occur that will interfere with your cognitive abilities. I'm just going to look at one or more. The circumstances they grow in may play a role. It's possible, depending on exposure, especially like the social, emotional, the language. So if a child is being raised in a very emotionally deprived or, you know, sensory deprived environment, it will show in the scale. So maybe their overall cognition is okay, but they score low in social, emotional, in language, and therefore we can, you know, give parents like advice on how to improve. Mental abilities are developing only till age 6. By age 6, it's more consolidated. After that, you can further enhance your abilities. So if somebody has an IQ, okay, a cognitive IQ of, let's say, 70 at the age of 6, so 70 puts them in the intellectually disabled group. So they are not going to progress and become of normal cognition after that, okay? So usually, you know, it's some kind of insult that happened, or they're, you know, globally developmentally delayed. So that's what I'm saying. Usually your IQ by age 6 is going to be the IQ you're going to live with for, again, your life, but you can enhance your abilities. So people can move within the range. So if you're within the normal range of 90 to 110, you can, and let's say your IQ is 109, you can move to 110, 111, so, but still stay within the same range. It's very unlikely that you're going to move into the superior range of 120 or 130. It's many points. And so people don't jump from like section to section, if you will. All right, so this is a very objective way of assessing intelligence. Then we move on to, okay. So habituation and dishabituation, again, concepts. So habituation to a visual stimulus. So when you see something repeatedly, it becomes something that you're familiar with, okay? And so you start to then pay attention to novel stimuli. Older infants need less time to look at things to habituate, okay? So they kind of screen the area. Okay, that's familiar. So they move on to, okay, that's not familiar, okay? And so this rate of habituation or recognition indicates brain integrity. So the higher or the better the brain integrity, the quicker kids are at figuring out, oh, that looks familiar or that is new, versus somebody who's, intellectually disabled where, they could spend a very long time still not able to figure out what's new and what's not. So we move on to categorization. And this is a very essential skill. We use it all the time, right? I mean, when you're studying for your exam, you make tables to simplify life, okay? We categorize to simplify, okay? In your head, I like these people, I don't like these people, I like these colors, I don't like these colors, I like this food, I don't like this food. So categorization. So how is knowledge stored and manipulated? And it's by categorization. So the basic unit of organization is the concept of category representation, okay? So this helps to simplify the diversity of the environment, to make life simple, okay? So you have simple perceptual discrimination and memory abilities. So you need to be able to discriminate visually or by perception, by senses generally. And you need to have an intact memory, because there's no point, like if you can discriminate but you can't remember, then you're not really going to categorize, okay? It really capitalizes on the visual selectivity of infants, that they look at some stimuli more reliably than others, again, depending on interest, okay? And remember, depending on memory. So if I recognize something, I'll move on. If I don't recognize because of my memory, I'm going to be fixated and stuck. And also, this is another reliable behavior, is that we know that there's always a preference of looking at new things, novel stimuli, okay? So this is what it's called. It's called